Hello everyone, welcome back. This is Engineer Hussein Wasapi, and in today's video we'll be looking at a chemistry revision of 2017 past paper. So before we get to it, don't forget to like and subscribe to this channel. Alright, let's begin. Now the question reads to say the diagram below shows the cooling curve for a liquid. So before we even get to answer this question, let's understand what a cooling curve is. So a cooling curve is simply just a curve that shows you the decrease in temperature with respect to time, how the temperature is reducing in a given time period. That is what we're calling the cooling curve. So this curve is showing us the decrease in temperature with respect to time. Alright, let me just erase this. Now going back to our magic pen. Now, with that said, we need to understand that it's not always that we might have a cooling curve. At times we might also have a heating curve. They will specify if the curve is for a liquid or a solid. In this case, we're having that of a liquid. So whatever substance state that has been given in a question will always show you the first state of matter that will be present in your curve. So in this case, the diagram below shows the cooling curve for a liquid, which means in our first portion here, the first state of matter we'll have will be that of a liquid. As you can see, that as the temperature is reducing in that direction, we're finding that the line is being slanted. Then at a certain period of time, you'd find that it's being flat. Now get to understand why that is so. Now in the first part of the question, they're asking us to say, in what state of matter is a substance in area A? We said in the first part, we'll always have the state which is given in the question. So it is what? Liquid. So here the answer is what? Liquid. Like that. Now once that has been answered, we need to move on to B, which says what name is given to the point labeled B. Now if you look at B, the flat line there, it's simply flat because the temperature at that point remains what? Constant in a given period of what? Time. In this region, which is B and C, you expect to have two states of what? Matter. So in this state, we need to understand that the substance is in liquid and what? Solid. And the point at which this substance is changing or transitioning from a liquid to solid is a point regarded to be what? A freezing point. So the name given to the point labeled B is simply what? Freezing point. Freezing point, just like that. Now, if you are told to say what states of matter is a substance at BC or region BC, that's why you have to say liquid and what? Solid. But now, if you look at position D, the substance is now completely that of a what? A solid. So in C, it states to say in what states of matter is a substance between B and C, of which I did make mention of that, which is what? Liquid and solid. Just like that, liquid and what? Solid. Then D says explain the reason why the thermometer reading remained constant between points B and C. The reason why it's a flat line, or the reason why the temperature has remained constant, is simply because all the energy, or the heat energy to be precise, is being used to change the state of matter of that particular atom substance. Now others would say that the thermometer reading remained constant between point B and C simply to allow the complete change of what? States. Okay? So to allow the complete change of what? State. I hope that's clear. So questions would always be phrased in such a manner. Why is it that the temperature reading remained constant? That's why you have to say that all the heat energy was used to change the state of that particular substance. Now he says explain what happens during cooling in relation to the heat content of what? A substance. Now when we talk about heat content, we're talking about the amount of heat present in a particular region or what? Substance. So we need to explain what happens during cooling in relation to the heat content of a substance. Now what you have to understand is this. Now as the heat content or the amount of heat reduces, there will be a loss of what? Temperature. Okay? So the heat content will reduce as heat is lost during what? Cooling. That's what will happen. So be mindful about that. So the heat content will reduce as heat is lost during cooling. I hope that's clear. So be mindful about how you go about solving these type of questions. Remember that the state given in the question will always give you the initial state of matter that you start with in your question. All right, let's move on to the second part of the question. Don't forget to like and subscribe.